Hello, welcome to this lesson in which we are going to look at organic chemistry and particularly reactions of benzene, which are not electrophilic substitution reactions. Okay, so that's what we are calling here other reactions of benzene. So today we are going to look at other reactions of benzene. Now, when we talk of other reactions of benzene, we simply means reactions of benzene which are not electrophilic substitution reactions. Remember previously we have looked at a number of electrophilic substitution reactions of benzene, but now we are talking about, are there other reactions of benzene which are not electrophilic substitution reactions? Those are the ones we are looking at today. Okay, so examples, we have hydrogenation of benzene, which from the name suggests addition of hydrogen to benzene. Hydrogenation means addition of hydrogen. Okay, then the next one is chlorination of benzene. Now, if hydrogenation was addition of hydrogen to benzene, then what is chlorination of benzene? Addition of chlorine to benzene. Then lastly, combustion of benzene. Combustion means burning a substance in presence of air, and particularly in presence of oxygen gas, since oxygen gas is the most reactive part of air. Okay, so let's look at these reactions one by one, starting with chlorination of benzene. Chlorination of benzene is simply reaction of benzene with chlorine in presence of UV light, ultraviolet light, or sunlight. Please note these conditions very, very well. So this reaction takes place in presence of ultraviolet light, which is actually contained in sunlight. So if somebody talks of sunlight, they actually also mean ultraviolet light, because sunlight contains UV light. So what's the reagent for this reaction? The reagent is chlorine gas. It is the reacting substance that reacts with benzene in this case. Then what is the condition? What are the conditions? The condition is presence of ultraviolet rays or sunlight. So this reaction will only take place if there is sunlight energy or ultraviolet rays. And what is the product? The product is called 1, 2, 3, 4, 5, 6 hexachlorocyclo. It is called 1, 2, 3, 4, 5, 6 hexacyclochlorohexane. Why hexa? Because from here you realize that there are actually 6 chlorine atoms that will be attached on this substance. Then hexachloro, of course, means 6 chlorine atoms. Then cyclohexane means a cyclic hydrocarbon which contains 6 carbon atoms. So let's look at that reaction. We have benzene reacting with 3 molecules of chlorine, which also means 6 atoms of chlorine, because each molecule of chlorine contains 2 atoms of chlorine. So 3 molecules, 6 atoms, in presence of ultraviolet rays or UV light or sunlight. And what do we form? 1, 2, 3, 4, 5, 6 hexachlorocyclohexane. This is the structure. 6 chlorine atoms attached. 1, 2, 3, 4, 5, and 6. And cyclo means that the compound is cyclic, like you can see here. It is cyclic. It is in form of a ring. Okay? Then hexane means that there are 6 carbon atoms and it is an alkane. So you can see that there is 1 carbon atom here, another one here, another one there. Those are 3, 4, 5, and 6. Okay, this is number 1, this is 2, this is 3, and this is number 4, and this is number 5, and lastly number 6. So there are 6 carbon atoms. So it is called 1, 2, 3, 4, 5, 6 hexachlorocyclohexane. That's the product. Okay, so you'll meet this often in examinations, but this is just a simple illustration. Then the next reaction is called combustion of benzene. Combustion of benzene, like we said, is burning benzene in air. Benzene burns in air with a yellow sooty flame, or what we call a luminous flame. And what is the reagent for the reaction? The reagent is oxygen gas, which is in air. Okay? Then the condition for the reaction is heat. You must burn, you must heat the substance. Okay? You must heat benzene. Then the product is carbon dioxide and water. Why is it carbon dioxide and water? Because benzene is actually a hydrocarbon, contains carbon and hydrogen. So when you burn any hydrocarbon, you must form carbon dioxide and water. Okay? Then benzene burns with a sooty flame because it has a high carbon to hydrogen ratio. Means that there are more carbon atoms than hydrogen atoms. Okay? Means that the ratio of carbon atoms to hydrogen atoms is very high. So because of that, benzene is called unsaturated. It is supposed to have a certain number of carbon atoms and hydrogen atoms, but then since it is unsaturated, there are less hydrogen atoms than expected. So when you burn this substance, there is going to be unburnt carbon. Some of the carbon atoms there will combine with oxygen to form carbon dioxide, but some of it will not. Why? Because of the high carbon to hydrogen ratio. So that unburnt carbon is what we see as a soot. Okay? Good. Now this is the reaction. Benzene reacting with oxygen gas to form carbon dioxide and water, like any other hydrocarbons. Then this reaction is important in the laboratory for testing, predicting if a substance is containing a benzene ring, if a substance is aromatic. Why? When a substance is aromatic, it is always going to burn with a yellow sooty flame. But this reaction does not confirm that that substance is aromatic. It simply predicts whether it is aromatic or not. Okay? Why doesn't it confirm? Other unsaturated hydrocarbons like alkenes and alkynes also burn with yellow sooty flames. So it will simply give you an idea whether it is aromatic or not, but it will not confirm. Good. So thank you for listening. That has been our lesson for today, and have a blessed day.